Recording started. Hi, and welcome to this July Bitcraze Dev meeting. This time we'll have a presentation about simulation by Kimberly about the Webot. And yeah, please do.
All right, thanks. So it's going to be a full house today. This is our busiest dev meeting so far. So that's great. So I'm going to explain a bit about simulation, about like the Webots simulator in general and the Crazyflie simulator model that I've made a while ago for it and updated it recently. I don't have that many slides because I'm expecting to actually give a lot of hands-on stuff with the Webots, just to kind of like demo a couple of things in there right here on my computer. So yeah, so that's kind of how it's going to look like. Yeah, let's go to the next slide. Of course, for simulation, yeah, there's a lot of simulators out there. So there's a lot to choose from. So of course, like many of you are probably maybe familiar with Gazebo already from to connect with any ROS. Webots is also one one of them, and that's also kind of the one that I'm already going to use. There's also some simulators that are perhaps have a little bit better rendering model in there. Like NVIDIA Isaac is gaining a lot in popularity. They also have a Crazyflie model, by the way, not implemented by us, but by somebody. And AirSim, that's a project by Microsoft. And then there's also kind of like a couple of simulators out there that are more meant for swarms. Like I've used Argos before. Don't think it has been very maintained recently, but you also have PyBullet Gym that also has the PyBullet Gym drone package. That's also based on the Crazyflie. So everybody's using Crazyflie these days. Also a simulation. So these are just kind of like the options that are out there. But I'm going to talk about the Webot simulator, which is made by a small company called Cyberbotics. They are currently located at pretty much on campus of EPFL, and I think that's also where the Webot simulator started. Yeah, and so yeah, basically it has like the main building blocks of a generic robotic simulator, like a random model and collision model, sensors. So like here the multi-ranges that you can see right here. And luckily for us, or else we wouldn't be able to use it at all, they have also some kind of propeller physics. But I would perhaps for those specifications, I would definitely you should probably try to take a look on their website. Also, it's per robot or per drone. You can also add a controller. So that does something with the propeller. So that yeah, or actuator, let's say, in more generic robotics terms. Yeah, so that's kind of like kind of the block elements that are in the simulator so far. Yeah, and yeah, actually, as a robot, the Crazyflie model is actually really simple. Uh, so like it only has like four moving parts, which are the propellers. So actually, the simulator was just kind of like not that difficult. Then, for instance, if you have like a full multi-DOV arm or something that you have to simulate. So pretty much, it has like a base that has the kind of looks like the Crazyflie without the propellers, and that has like an simulated gyro attached, simulated IMU attached, a mocap. They call it GPS, but it's actually perfect GPS. But of course, yeah. So, and of course, like it has the motors where the propellers are attached, which have the propeller physics that they simulate in Webots. So I think probably the best for me is now to actually present my full screen, so I can actually start up a new Webot simulator. And actually, they've just released their they just had their own 2023B release. So that is just what I'm going to start up. It works fine in Windows, but if you were wondering. Yeah, so this is actually This is actually how the Webot simulator looks like. So I've already played around a bit with the Crazyflie already, but let's kind of start maybe from scratch. So if you now currently the robot of the Crazyflie is a standard model or sample world in the Webot universe. So if you would like to just very simply open that and just play around with it, then you go to Open Sample World, you go to Robots, Bitcraze, Crazyflie, and this Crazyflie is just the basic one. And that's pretty much the one that you see here, right here. So if you kind of look here, there's like a nice rendered model. It also have a collision model that you can see right here. And this like and where it's kind of currently facing towards. So the Webots simulator, they don't use UDRFs or SDFs like a Gazebo does, but they kind of set up their robots as in proto files, they call it. So this is something that you can just implement right away. But if you want to, for instance, look at the original proto source, you can, of course, take a look here. Of course, any change that I'm doing in here, I would need to save it somewhere else because it's in the installation file. But that is kind of like how a proto file looks like, and that's how you kind of use to assemble your robot either directly from the file, but you can also do that in the simulator right here. So that's all dandy. So these are kind of indeed like the propeller that I mentioned, which is kind of maybe the most important part from the Crazyflie. So if you kind of look in there, I'm not able to select them because I don't have the full controller there. But like, you have the center of thrust. It's pretty much where the location is from the motor. What are the thrust factors? Let me just double check. Thrust constant or torque constant. Don't quote me on these, that these are perfectly the right constants that a real Crazyflie has, because I started that myself as well. But I think that is mostly because Webots has a different type of propeller model than Gazebo has, for instance. So there might still be something off there, but if you if you zoom out and we can make it. Oh, I don't want to save, of course. If we want to make it fly, and there's this controller right here that I can edit. So this is just styled nicely in Python. And now this is, for instance, just like, executing a very simple PID controller that just makes it fly to a fixed height, and you can control it with your keyboard. So let's start it. Yeah, there you go. Yeah, so this is kind of also one of the small improvements I did with the latest one, is that now when it rotates, it has this kind of like this helix that you can kind of see. It's just purely aesthetics, and some improvements to the controller as well. But what you can do is just you click on the screen and you can use the key buttons on your computer to control the Crazyflie. So that is all cool. You can even rotate it. And if you like to do something else with it than just this, then of course here, if you look in the code, you can also use VS Code to change the code, of course. You can see, like, what the keyboard actually did. So if you would like to replace that with your own state machine, and I can kind of show that in the other controller later as well, then you can, for instance, like overwrite the sidewise desired or forward desired with, yeah, whatever you want the Crazyflie to do. So that is. It also has a camera. It's a bit better than the AI deck camera, but it's just like, yeah, at least you're able to see what the Crazyflie is seeing, if in case it had a camera. All right. So let me just close it down, and it's going to open up the simulation again. Or not the simulation, I mean the slides. So yeah, that's kind of like what I've shown here so far. It's going to be all brief and short for this one. So there's also, as you saw already, there's like also a camera attached that I forgot to mention before. But I've also attached a multi-ranger, at least for things like autonomy. That might be also very handy to have the simulated multi-ranger in there. It's not, there's no render model of it, so it's just the sensors. But at least in the next example, I can kind of show the multi-rangers actually already being enabled and that you can see them in the simulator itself. So let's open up a different sample file. Robots again, Crazyflie, and the Crazyflie apartment, which is a new sample file that I've pushed to the Webots source codes. And this is now actually.
We are not seeing your screen.
Oh, whoops. Thank you for reminding me. I knew this was going to happen. That's why we have host people. All right. Cool. So, okay. So you now see the Crazyflie flying in a little bit more complex apartment, because you can of course add that. And now you can of course also see that in the sidebar, there's a lot more options than the previous more simple, which pretty much only had a floor. Yeah, it only had a floor. So you cannot do that much obstacle avoidance with that. But here in this apartment, you can. It's a nice little apartment right here. So let's go back to the Crazyflie, because now it's just standing still. It's a bit. So you can still do the same thing as before. You can make it fly with your keyboard. Or there's also new functionality in there as well. You can start autonomous mode, which is very simple actually. It's doing wall following, and you can now also see that you're able to see the multi-ranger now. So this is already part of the standard proto. Even the simple world had that, but now at least like this in this simple, I've enabled the sensors to be viewable so that you can kind of see what's happening. So, and also it's always following the Crazyflie as well. So while it's flying, we can take a quick look also at the control right here. So I've added like some extra code here that's doing the wall following, that has the wall following state machine. And that pretty much is then, if that's like, if autonomous mode is enabled, it replaces all the, sideways desired and forward desired or yaw desired with the one that comes from the wall following state machine. So that is I'm not sure if I'm able to open up the wall following itself. I'm not sure if I can. Maybe I can. There you go. So yeah, and this is a lot of code. So you can check it out for yourself. It's supposed to be. And also, fun fact, actually, we have the same wall following code in the CFlip as well. So this is actually just pretty much a copy paste of that same wall following state machine. That's the CFlip, one of the CFlip examples that you can actually run on the real Crazyflie as well. Where's the? I think it's now. Let me try to find the Crazyflie again. So I think you get the point. Actually, I think at this point, maybe it would be nice to kind of like see it crash finally, because I know this is a point that it will start crashing perhaps, or maybe it doesn't. Yeah, there you go. It flipped. Yeah. So the wall following algorithm with the multi-range is not great for closets, as you can see. But that's fine. You can try the simulation. So that's kind of like, maybe it makes it already easy for your development process. Perhaps it's handier to not, to not have, like if you want to do wall following in an environment where you have a lot of these situations, maybe you have to kind of think about some other strategy right there. Yeah, well, moments. Slide. Yeah, so that's kind of like what I've showed you guys. So like the wall following part of the Crazyflie, that is like a separate module. Then you have the controller that's in Webots. So you just have to make sure that the wall following one is very, yeah, very modular in the sense of it just has the multi-range inputs and it has the velocity as output. So just to make it easier for yourself, so that you can, for instance, use it in the C flip as well. So that you can kind of iterate between both the real Crazyflie and the simulated Crazyflie. Kind of try to tweak your autonomy bit a bit in there, and just try to kind of like, yeah, how do you call it, like yeah, it's, of course, it's like the simulation. Of course, the dynamics are very simple, so it's not completely real to sim in that sense. But you can do already quite a bit by doing this type of development process for your work, and it's really going to save you a lot of time for sure. Yeah. So, like, in terms of future plans, there is also kind of like, at least for to improve the simulator, I want to improve the PID control. Now I've written a very simple controller that can only do like forward velocity and sideways velocity in top position. So I kind of want to make it able to also input, or that you can give it a position reference as well. Then of course I am hoping to at one point also make a ROS2 package for Webots for their repository. So that's, for instance, that you're able to run the simulator very easily in ROS. Once that's done, to implement into Crazyflie 2, which is a project that I've been also working together with Wolfgang Honig, but that's pretty much his project, and we're just kind of co-maintaining it. And perhaps, maybe not having ROS in between, maybe having direct connection with CFlip. But perhaps maybe we can save that also for like the next iteration of the CFlip, if I can see Arna's. Yeah. So, but that's kind of like the global plan. So just a very quick demonstration of, yeah, the simulator and what our new plans are. So yeah, that's it.
Is it time for questions?
Yes.
Then I have one.
Yeah.
So this is running only stabilization algorithm, right? Nothing else from nothing from the actual firmware of the Crazyflie.
No, it should be able to run the, like, the Python bindings. I've done that before.
Mm-hmm.
Of course, the problem is that this is actually an example within the Webel simulator, or like the Webel's installation. So Python bindings in there, like, it needed to be also something that worked on all OSs and all. So, and yeah, like this I've written this by a PD controller, like just in an hour or so. So it was, yeah.
The thought was that if we could, it would be extremely useful to connect it to CFlib, because then we could run the client against it. We can run, I mean, you could really develop with it. But indeed, the difficulty is that then this needs to emulate a lot of the Crazyflie behavior. So yes, maybe CFlib 2 can be architectured in such a way where we can attach to simulator as well as real Crazyflies. Maybe
yeah, exactly. Like, at least
better
in the
approaches. Yeah.
at least in the Webot simulator, you're able to simulate communication as well. So my idea was then to, like, go all the way and just make a simulated crazy radio in the simulation. Maybe it's going too far. Maybe, perhaps.
I mean, there's been a lot more work about swarms and peer-to-peer communication. And it is very hard to develop these kind of things.
Yeah.
Because everything moves everywhere, and it's very hard to debug. So yes, it would be extremely useful.
Yeah.
But yeah, quite hard to implement though.
Yeah, it's kind of the
maybe
question
again,
where we want to go.
maybe
and,
as at API level, one of the problem right now is that we don't have any good API level for Crazyflie. Like, there's no API for Crazyflie. There's packets, radio packets. But if we can reach a point where we actually have an API for the Crazyflie, we have a bunch of functions that a Crazyflie implement. And same thing for peer-to-peer. If you have a branch of function that can write a Crazyflie app against, then it will not have to run the same thing. It will just have to implement the same API, and it might become possible to use that as a development tool.
Yeah,
exciting.
Yeah, exactly. Like it's really the question of where to simulate. We had, for instance, a master thesis project a while ago by people that pretty much simulated the full hardware of the Crazyflie as well, along with the firmware. So like all the things that can happen within like the embedded part of it. So that is something that we can also simulate with perhaps like connecting Webots to it, but then maybe it becomes a bit too detailed. So yeah, so it's kind of like where do you draw the line?
Yes. So yeah, sorry, I forgot to say. If you want to ask question, you're very welcome to either talk or write a message. We can write. We have a chat in Meet, and there is a question actually by message. It's good work. Is it possible to simulate multiple Crazyflies and control them simultaneously with ROS1 or ROS2?
Well, of course, it's possible to control multiple Crazyflies. You just have to make sure that in terms of the controller, that not like, for instance, like now I have the Python controller, and they're kind of sharing the wall following as well. So I think I have written in such a way that the owner should be in the one that initiates the object. So it should be possible to have multiple Crazyflies doing wall following at the same time in simulation. Yeah. So so yes, that should be possible. It hasn't been. I haven't been able to show it working yet. But theoretically, it should be possible. With ROS1 or ROS2, that's a good question. That's one of the future plans, let's say. I first want to make a ROS2 package for Webots, and that's only done after I've improved the PID controller. And then once the ROS2 package for Webots actually works, then I want to implement it or set in this example to use it with Crazy Swarm 2, which is based on ROS2. So there's some intermediate steps in there, and I just have to find time to work on it. So, but it's in progress. Yes, soon, hopefully. But you can just go ahead and try it out yourself. There are instructions how to make a controller work with ROS2 already with different robots. But if you go to the Cyberbotics website, you can kind of go for that as well. But we have a couple of other questions. I see.
Yeah. Stefan says, hi, thanks for the presentation and examples. I have a brief question. It seems that the wall following code is in Python only.
No.
And the wall following code uses CFlib, which is Python? Question mark. Yeah.
Yes,
So
thank you for the presentation. But yes, originally, I guess the code you provided was C and C++ and Python as well. The small example you presented first, and after that you presented a nice example, wall following, this nice apartment scene, and the code you show us is more complex, but is on Python, I guess.
It's indeed in Python, but actually we have the exact same code available in the Crazyflie firmware as a app layer example. So it's in C as well. The reason why I have two types of controllers. The first in C was for the simple Crazyflie because that was the original that I've implemented so far. But after that, I've decided to make also a Python version of it because not everybody is very adept to C. So pretty much both things are doing exactly the same thing. But yeah, I happened to have the Python version for the wall following one because yeah, it's just a little bit easier to change that. But we have, at least for the Crazyflie firmware, we have the wall following example in C for a fully onboard autonomous example. But we have it both in Python and C actually for the Crazyflie itself.
But you confirm that this C code is not available for Webots.
No. It's something that you can implement. You can, for instance, also take the C-based controller, and you can take the wall following state machine from the Crazyflie firmware itself, which is also compactualized. Like it's also kind of written in a way that you can take those piece of code and import it somewhere else, as long as you just provide the multi-ranger inputs, the yaw and the I think, and it has as output the velocity, the velocity that you want the Crazyflie to be with. So currently, as a standard example in Webots, it doesn't exist, but I would say it would be very easy to implement. And you can probably ask a question on discussions, like discussions.bitcraze.io, and then I can probably point you in the right direction how to do this fully in C code. So
Thank you for the help and for the answer. Yes, I understand how it's possible, but I will try to send this question to have more advice about how to do. Thank you.
Yeah. No worries. We have a couple of more questions, perhaps.
Yes. So in Webot, do we have easy access to the 12 states X, Y, Z, X, Y, X, V, no, VX, VY, VZ, and all the acceleration? I would like to implement an algorithm based on the Mellinger controller.
Ooh, Mellinger. We do have Python bindings for the Mellinger controller, actually, but we don't have it in Python. So if you would like to try it in Python, that will be very interesting. Yes, that is maybe it's good for me to kind of show it in the Webots controller again. One moment. Because then I can kind of show you where you can kind of get this information. So I believe that the GPS get values, which is the mocap, let's say, has X, Y, and Z values. So you can kind of see that here, here, and here. It does not have velocity, so I kind of had to calculate that myself. So that is something that but maybe there's already something in there that actually gives you full post ground truth information, but I had to get the velocity X, Y out like this. But you can go exactly see it, how I've done, or do it your own way. And of course, body fixed velocity. So roll, pitch, and yaw is fine, because you can get that directly from the IMU. And you can also get the yaw also from roll, pitch, and yaw from the gyro. So that kind of gives you the full state, but you would need to perhaps hack around a bit for maybe the full states. So it would be weird. They should have some flow deck plugin or something like that, or something that just gives velocity. But I wouldn't know. I haven't found something like that. I hope that yes, awesome.
Yeah, and I guess since it's a simulation, doing this kind of math is perfect. So it's going to work out. If you want everything down to the jerk, you should be able to apply the same technique, right?
Yeah.
Yeah. Great.
One more question, I guess.
Yes. Did you ever try to run a simulation with an integrated graphic card like Intel?
Yeah, well, so I am running this on a laptop, but it is kind of a gaming laptop. So what I can do is, for instance, show you how it looks. Let's maybe have a.
Is it graphically taxing software?
It's not very graphically taxing, I would say, but I can, for instance, put my laptop on a. Hey, where did the Crazyflie go?
It was upside down on the shelf.
Yeah, I know, but I restarted the simulation. I'm just going to. So
is there any randomness in this simulation? Will it end up upside down on these shelves for every run?
I think there's not now there's no random seed. So last time it also did there, but you can put some kind of random seed in there. I
Okay,
don't
so
know
there
exactly
is
what.
some.
Yeah. Okay, so this is on my computer's. I think it's using the Radeon graphics card now. So okay, it's a little bit slower, and it's not running. It's running at 70% now. But this is like with full apartment also kind of rendered. So it's, I would say, pretty okay. It could be better. I think it's definitely a lot. Yeah, let's say not as power hungry as, or let's say graphics hungry as Gazebo is. But yeah, perhaps like the graphics are maybe a little less. But yeah, I
Just
like.
out of curiosity, what graphics card do you have on this computer?
Yeah, good question. Was it a 3?
Your integrated graphic card is a Vega, so you have a bit better than a
Yeah, exactly. Yeah.
Intel actually, because this computer has a Ryzen chip and one of these fancy NVIDIA.
Yeah, it has an NVIDIA GeForce RTX 3500 or something like that. But that's, I'm not sure if this is actually running. I think this is now on the rise. The AMD.
But that's a Vega.
Radeon.
Yeah, Radeon Vega 8 or something like that. So it's a bit better than a Intel integrated graphic.
But I think this can run on an Intel as well, but or like a lesser graphic card, but I think the real time factor will be a lot lower, for sure. So you just have to be a bit more patient.
More patience though.
Yeah.
I mean, the fact that it can slow down simulation is good. Because then you always get good results. It's just that you get them a bit more slowly, maybe.
Yeah. But at least you're able to run something. Like if you want to run AirSim or anything that's based on Unreal Engine, then you're going to definitely be in some issues. But yeah. But as you can see, the rendering it's nice, but it's not super high end. But for a lot of tasks, you don't have to have perfect rendering usually. Yeah, and I think even was it like Lorenzo, you guys also used didn't you use Webots also to train the AI deck for the IMF competition?
Yeah, we did so, but we didn't use the controller actually, just to acquire the dataset.
Yeah. Okay. Yeah. But yeah, then yeah, because the AI deck, of course, is not super high res, so then
yeah,
it should be enough. All right, let me just return this.
One more question. Is it possible to use the commander.send setpoint roll pitch your thrust in Webot? So I'm assuming it's about, is it possible to use CFlib functions?
Not yet.
No, but I'm assuming, okay, is it possible, is the function you can use similar to that? Can you set roll pitch your thrust?
Good question. I have to double check that in the. Let's see if I've written a PAD controller for that, because it really depends here. Like now, I've really made a PAD controller that is. Wait, let me just share my screen again so you guys see what I'm actually looking at. So now I actually made a pretty much hard-coded PAD controller for fixed height and velocity. But I think if you wanted to just only control the roll and pitch and yaw, then you can probably change this controller to output those commands too. So it's kind of just you just have to remove like the whole velocity and position layer right here. I would say so. Like this is the velocity PAD controller. This is the altitude PAD controller, and that outputs desired roll, pitch, and yaw. If you remove this and then you make a controller that already gives the desired pitch and yaw, then that's what you get. But I'm not sure how easy it's going to be to control it, to be honest. But it maybe perhaps if you want to make your own controller and then input that, then yeah, that's fine. But then I would actually recommend you to kind of start from scratch, actually. But you can take this as kind of like a good example of like how to do the motor mixing and everything. So yeah. So currently it's a bit hard set to like giving it velocity commands and a fixed height. All right.
Good. But if there's not any more question, I think we can be done for this presentation. Yeah, for whoever is looking at that on YouTube later, thank you very much for watching. This video is going to be added to a playlist we have in YouTube that's called Meeting. We will also add it to a page, dev meeting page on the website. So if you want to see a list of previous and future, hopefully, dev meetings. The next one will be in September. We'll have a small break in August. But we will be back in September for another dev meeting. Thank you.
All right. Now,
Thank you for the meeting and the presentation. Yes.